Today we're going to be looking at solving equations by graphing. The first example is to see if the point 214 is a solution of the system of equations. We do that by substituting those in to the equation. When we look at the first equation, y equals 4x plus 6, and we plug 2 in for x down here, 4 times 2, of course, is 8 plus 6. We find that y equals 14. So yes, it is a solution for the first equation. Since x equals 2 and x does equal 2 in our point, that means that 214 is a solution to this system of equations. The second one is very similar to the first one. Is 1, 2 a solution of the system of equations below? Once again, we substitute the x in. We're using the first equation, 4x minus 2. We plug in the 1 for x, and we find that 4 minus 2 is 2, and sure enough, y is 2, so that is true. Looking at the second equation, y equals 6x plus 1. Once again, we'll plug in 1 for x. 6 times 1 plus 1, 6 times 1 is 6, plus 1 is 7. But our point is 1, 2. It is not 1, 7, so that is false. Y is not 7. Well, anytime you get one of these to be false, then 1, 2 is not a solution to this system of equations. They must both be true in order for it to be a solution. Solving the system of equations by graphing, the first one we have y equals 2x plus 3. We know that 2 is our slope and 3 is our y-intercept. So we come up to 3 and put a point there. And if we put a point right there, the slope, we think of it as 2 over 1. And from that point, we go up 2 and over 1, which is right there. And now we put a line through it, and it's already drawn for us. So this line right here is the first equation, y equals 2x plus 3. Looking at the second equation, it has a negative 4 for slope and a negative 1 for y-intercept. So it's going to be right here that it is the y-intercept, and from there we go down 4 and over 1. So there's our other point, and we put a line through it. So this line is the line that goes for this equation, y equals negative 4x minus 1. Our next system of equations, y equals 3x plus 1, and y equals 3x minus 3. So this one has a y-intercept of 1, which would be right here. And from there, we go up 3 and over 1, and we put a line through it. And so there's our line that matches our equation, y equals 3x plus 1. The one at the bottom, or our second equation, is y equals 3x minus 3. Minus 3 is right here. From that point, we go up 3 and over 1 and put a line through it. And that line is y equals 3x minus 3. Continuing on with our graphing, I want us to look at this when we have y equals x plus 3 and 2y equals 2x plus 6. If I divide this equation by 2, I get this equation because 2y divided by 2 is y, 2x divided by 2 is just x, and 6 divided by 2 is 3. So they're both the same line, so we've got to graph this line, y equals x plus 3, and we do that by putting the y-intercept here at 3. And since there's a coefficient of 1, we don't write that, but we know it's there in front of the x. We go up 1 and over 1, and there's our other point. We put a line through it, and that is the line that goes with both of these equations because they are both one line. So that is graphing using systems of equations.